talk about the transformation from the uniform distribution to the modal distribution. Okay, so I will use the word modal to just to refer to the non-uniform distribution for short. You can hear the word multimodal as well. In statisticians, they just use the word multimodal in order to refer to the model with many peaks. So for example, the GMM distribution or any other distribution with two peaks or two local maxima or two or more. Okay, so I use the word model here to just to use non-uniform to refer to non-uniform distribution. Okay, so the first thing is uh, I just start with the experiment like this. I draw random sample x and y, and I combine them in a table to display like this. Okay, so x randomly from 1 to from 0 to 1, y same thing. Now the CC is the color here. I will use x to color with this function. So if x smaller than 0.3, then I keep the color red, and then from 0.3 to 1, then I keep the color blue for each point. So the y is free. I don't care. I just use y later to draw random points, but then I will use x to color the table. Okay, now I don't use this one anymore. I will display the chart for you to like this. Okay, so you can see here and for x equal for from 0 to 0.3, it will give the color red, and then the rest will color blue. So basically this one, you can see that it changed the distribution in this case. So from the uniform distribution to the non-uniform, in this case 30% of the time you can observe red, and then the other 70% will be blue. Okay, you can change to anything. So if I change this one to let me change. The first thing is to about 5,000 samples, and the second thing will be to 50%. Okay, and then you can see the difference. There you go. So you can see here, this is the half, and then half of the time you can observe red, and then the other half of the time you can observe blue. Okay, so that's how it works for from uniform distribution to non-uniform. In this case, it's still uniform because you have the 50-50, so it's still uniform distribution. Okay, so but later we will modify things. Now I'm going to do another thing, which is to draw this one to uh, the histogram uh, of the two part like this. Okay, so you can see here, this is the same thing. This is like the same data set, but then I present it to the different part. So for this part, actually I just use a scatter plot in order to scatter or to distribute the points around. But this one, I just count the number in certain part. For example, it's from here to here 50%, and then here to here another 50%. I color the part. Okay, so if I change the coloring number here, like for 40 for example, you can see the other pictures with uh, less red and then more blue, and then here is the same thing. Okay, so this one is the very interesting point in the middle here, because this number is integer number. So each bin will be assigned in an integer number, and then this one is in the middle. So for example, between 0.4 0.3 something to 39, and then 0.41, it will count in the same bin, but then later it will draw in the different way. The first part here, which is the red, and then this one is the blue. Okay, so it doesn't matter as long as you um, you label the points. It will count and then it will draw in the histogram, but it will give you the different stack different stack color, and then you cannot get the picture wrong. Okay, so the next one would be I will draw the same thing with I will add one more layer like this. Okay, so this one is the same thing. I just give the count here for red and then blue. So red will be like something 2000 out of 5000, and then blue will be 3000. So if you plus 3 and 3000 and 5000, in total you have 5000 this is our sample number. So in total we have 5000 sample, but the 3000 of them will be blue and then 2000 of them will be red. Okay, so you can change the number and you can play around with this picture, and then this is the way we convert any non-uniform uniform distribution. So in this case, the R unif, which is the uniform distribution, into non-uniform. Okay, and then I can change this one to any kind of color. So I will have the second option here. I show you 40% of the time I will do red, but then the other 60% I will split again. I will split again. So if x equal to, maybe I will split 40%, I will give 30% more, which is 4 plus 0, 3. I will give cyan, and then the rest I will give blue. I will give the color blue. So how does it look like, the whole thing? There you go. So uh, between 0 and 0.4, it will give you the red color here. If between 0.4 to 0.7, it will give you I need to show you 7 here. 7 here. Okay, it will give you the color cyan, and then the rest from 0.7 to 0.73 to 1, it will give blue. Okay, let me change this one to an extreme value, right? So I will give it like 4.9, right? Nice. 4.8. Okay, so I plus another 4 here. Okay, so you can see here for 40% of the chart will be red, another 40% will be cyan, and then the rest will be blue. And then in here you can count the point, right? So our 5000 points, 2000 will be cyan, 2000 will be red, and then the red uh, will be blue, which is 1000. So 1 plus 2 plus 2 is 5. Okay, so that's it, guys. That's how you actually transform the non-uniform distribution to uniform distribution to non-uniform distribution, or the modal distribution. In this case, it's just the if then function here.